Welcome back to the Explainer. Today, we're diving straight into day 16 of our system design journey to unpack the core mechanics of event-driven architecture. If you've ever wondered how modern applications handle millions of complex interactions in the absolute blink of an eye, well, you're in the exact right place. Let's break this entire architecture down piece by piece.
But first, think about this fundamental question for a second. How do you keep incredibly complex systems fast and responsive? When an application grows, you've got dozens, maybe hundreds of different components trying to talk to each other all at once. If they all have to stop, call each other directly, and wait around for a response, the whole system literally grinds to a halt. It's like a massive traffic jam. The real challenge here is decoupling these independent parts so they can communicate seamlessly without ever having to wait in line.
So here's our roadmap for today. First, day 16, event-driven architecture. Second, producers, consumers, and events. Third, pub, sub, and event streaming. Fourth, understanding eventual consistency. And number 5, designing a notification system.
All right, kicking things off with part 1, day 16, event-driven architecture.
Moving right along to part 2, producers, consumers, and events.
Let's look at the very foundation of this entire concept. So what actually is an event? Simply put, it's the spark. It's the fundamental piece of data announcing that a state change just happened. It's absolutely crucial to remember that an event is not a request for something to happen in the future. It's a solid declaration of an indisputable fact that has already occurred. A user clicked a button, a payment cleared, a file was uploaded. That specific occurrence is packaged up as an event, and it basically becomes the lifeblood flowing through our entire architecture.
Next up, we have our event producers. You can think of them as the loud town criers of your system. They just broadcast what happened without worrying for a second about who might be listening. Their one and only job is to detect that an action occurred, like, say, a user submitting a form, create the event record for it, and just fire it off into the architecture. They don't know what happens next, and honestly, they don't care. This massive decoupling is brilliant because it means our producer can work incredibly fast, never waiting around for downstream tasks to finish up.
On the flip side of that, we have consumers. These are the highly attentive listeners, waiting patiently to spring into action. While the producer is shouting out into the void, the consumer has its ear right to the ground. The moment a specific event rolls in, let's say that payment successful event we talked about, the consumer wakes up, grabs the data, and executes its specific job, like generating a PDF receipt. And because they operate totally independently from the producers, we can scale up to thousands of consumers, or even add entirely new features without ever having to touch the producer's original code. It's a total game changer.
Which brings us nicely to part 3, pub sub and event streaming. So how do these events actually travel from point A to point B? We primarily use 2 major highways for this, pub sub or event streaming. In a pub sub or publish-subscribe model, events are actively routed to specific listeners. It's exactly like a magazine subscription. You sign up for a topic, and when a new issue drops, it's pushed directly to your mailbox, and then it's done. Event streaming, however, is a bit different. It operates as a continuous append-only log. Imagine a permanent historical ledger moving on a conveyor belt. The events are written to the stream, and they stay right there. Consumers can jump in, read the events from the very beginning of time, or just pick up exactly where they left off yesterday. It's incredibly powerful for systems that might need to replay history or process massive ongoing flows of data.
Okay, part 4, understanding eventual consistency.
Now, because our producers and consumers are so completely decoupled, we do have to accept a certain reality of distributed systems. And that reality is, for a brief moment, parts of your architecture are going to be out of sync. When a producer announces an event, your main database might update instantly, right? But the consumer handling the search index might take a fraction of a second longer to actually receive that event. For that tiny, split millisecond, the system is inconsistent. But eventual consistency is our guarantee that, as long as the events are processed, every single piece of the system will eventually settle on the exact same correct state. We are actively trading absolute, instantaneous consistency for incredible speed, fault tolerance, and massive scalability.
Let's put all this theory into practice with part 5, designing a notification system.
Let's map out the exact journey of a single notification, from the moment it's created to the second it's delivered. In step 1, the user takes an action. Let's say they just got a new follower. The application acts as our event producer and generates a new follower event. In step 2, this event is routed straight into our communication layer. Now, depending on our traffic, this could route through a pub submodel for an immediate push or onto an event stream for durable logging.
Finally, in step 3, our dedicated notification service, acting as the consumer, detects this specific event. It quickly grabs the user's data and triggers the actual push alert right to their phone. Notice how the producer application never had to worry about mobile push tokens or network latency. It just fired the event and immediately moved on.
By combining all these fundamental building blocks today, we've successfully architected a highly decoupled and scalable system. We utilized event producers to emit state changes, which were packaged as events. We leverage pub/sub or event streaming as a robust communication backbone. We set up isolated consumers to do the heavy lifting of sending the actual alerts. And we designed it all while fully embracing eventual consistency, knowing full well that a microsecond delay in delivery is a perfectly acceptable trade-off for a system that can handle millions of users at the exact same time.
As we wrap up this explainer for day 16, I want to leave you with a final thought to ponder. If we are heavily relying on eventual consistency, what happens if the alert being sent isn't just a simple social media like, but a critical security alert, or maybe a banking fraud notification? How does that brief synchronization delay change the way you might architect the consumer's response? It's a pretty fascinating challenge to consider as you start applying these concepts to your own designs. Thanks so much for exploring event-driven architecture with me today, and definitely keep questioning how the systems you use every single day are moving data behind the scenes.